Okay, remember what we have said in regards to this part of Science 14. We are trying to study the matter, and the best way to study something is to classify it. The matter is classified as pure substances and mixture. Matter is classified as pure substances and as mixture. And then we went further and found the subgroups of elements which are everything, elements which are everything that we see in periodic table. And the second subgroup in within the pure substances is compounds, which is nothing but elements, or one element is bonded together. So one atom is bonded with the other atom, or that can be of the same type, like on the case of O2 or H2 or so on, or can be combined with the other one, like NaCl or CO2 or CO and so on. When we are talking about mixture, we have again two subgroups. One of that is known as the mechanical mixture, and it is those type of mixtures in which you can visibly see the particles that are forming the mechanical mixture. And the other one is solutions. This was the subject of our study when we were talking about what the terminology that is used, like what is the solute, what is the solvent, and when they are combined together, what are they forming? Solution. And then we were talking about the concentration as to what does that number when we are saying 7.5 grams per liter represents, and what is the more concentrated one and what is the least concentrated one. And then we move to what makes it so that what are those, what is that quality that we define as being able to create a solution, to form a solution, and it is solubility. So solubility is the ability of the solute and solution and solute and solvent to form a solution. However, another very important part on the solution is that is known as the acids and bases. So uh, even in our everyday life, when we are either cooking or cleaning, we are dealing with some solutions, and some of them are bases and some of them are acids. Of them are acids, but it doesn't matter what they are, bases or acids, they are lying under the solutions. So this is what we see as the. Now, an acid is uh, is a material that is corrosive. So those are the qualities, properties of acid. It's a material that is corrosive. It has a sour taste, but never taste an acid. Reacts with the metals. So remember when what we said in regards to metals, so that are The first group and the second group are very reactive, and then the other groups that are kind of on the deep, they are transition metals. So acids likes to react with those elements on the periodic table, so reacts with metals. Uh, they are good conductor of electricity. What does that mean? Means that if you are putting two electrodes into an acid, then you will see that the electricity is the circuit is closed. So electricity is produced or electricity is provided, let's say. Um, And then another characteristic of acid is that the, the litmus paper it, that is blue, when it is dipped into an acid solution, is turned into a red color. Now, litmus paper is a paper that is used just to indicate what type of solution is the solution that you are testing on. It's the fact that the litmus paper changes doesn't mean that is the fault, quote unquote, of the litmus paper, but it indicates, it tells us, it shows us as to what is the solution that you are dealing with. So if you have a blue litmus paper and you are putting it into solution and you see that almost immediately it turns into red color, that means that the solution is a acid solution. Now, another very important characteristic of the acid is that has a pH that is less than 7. Now, let's talk a bit about the pH. What is this? The pH scale is a scale that indicates as how much acid or how much base a solution is. The pH scale runs from 0 to 14. Right? Goes beyond that, but for us it's fine to say 0 to 14. And right in the middle at 7, there is a neutral solution, not a base, not an acid. An example of a neutral solution is water. And then whatever is less than 7 is known to be an acid solution, and whatever is greater than 7 is known to be a basic solution or base. This is an acidic solution. Okay, so the more higher you go into, so higher than 7, it is becoming more basic. And the example of most acidic solution that we know and we can relay on, and it's kind of well known, is the hydrochloric acid. So, and you know that drain cleaner is something that we use even in our household. Not so much hydrochloric acid, but drain cleaner is something that we widely use in our everyday cleaning our home. So the this is the explanation for the pH scale, and it is a scale that is giving us an idea as to how much basic and how much acidic is a solution. If it is greater than 7, close to 14 is the most basic one, and less than 7 close to zero is the most acidic one. And right at 7, what we have is water. Now, when we take a look at the properties or characteristics of a base, the bases taste bitter. Okay, but again, do not drink acid, do not drink bases. They are dangerous. And when we have a red litmus paper and we put it into a solution that is a basic solution, then it will turn into a blue color. When you touch the base with your 2 fingers, then you will feel that it is slippery. As we explained when we explained what is the pH scale and how is it working, then the basic solutions have a pH that is more than 7 and closer to 14, the stronger the base is. Same acids, same as acidic solution, basic solutions are corrosive as well, and they conduct electricity. Now, when we have an acid, then it is neutralizing the base because an acid reacts with a base. And when we have a base, pouring it into an acid will neutralize it, meaning that the pH will go, if not 7, close to 7. So it doesn't really matter when we are adding a base into an acid or an acid into a base, then what we will see in terms of the pH is that will come, if not 0, close to 0. Understand? Now, we often use the pH that is known as the pH strips or pH indicators. There are tons of indicators that are used in chemistry. However, for what we will see in Science 14 is the blue litmus paper and the red litmus paper. So this is a red litmus paper and this is a blue litmus paper. When you drop a base into the red litmus paper, then it turns into blue. And when you drop an acid or you put the blue litmus paper into an acidic solution, then will turn into red. Those are the 2 indicators that we use on Science 14 in terms of defining what type of solution you are dealing with, acidic solution or a basic solution. However, just so you know, litmus papers are not uh, the only indicators that we use in chemistry. Actually, there are plenty. Okay, so now we said that uh, an acid and a base reacts with metals, especially an acid reacts with metal. Now, when we have a material, a solution that is very acidic or very basic, that they are extremely dangerous, and you probably have noticed that as well when you are saying that when you are looking at the label on how to use the pipe cleaner, let's suppose, uh, that you are buying at Home Depot or Canadian Tire or anywhere for that matter, and then you are looking at the label and they are saying some of the materials are saying that they are not safe to use in copper pipes. It's good to use only on plastic pipes. So the reason that you have that indication there, that uh, reminder there is because what is happening, being very acidic or being a very basic solution, uh, will as soon as this solution is in contact with a material, then will happen that is known as the corrosion. So corrosion is, quote unquote, the solution is eating up the material, okay, is wearing away the material by through a chemical reaction, okay. Very often is seen and it is perceived as the oxidation or acid rain, but actually this can be in a big umbrella. It can be called, it lies in under the corrosion. So when you see, let's say, and you probably have seen it unless it is a very brand new car, that a car, and especially if it is old, you will see that there is some rust on it. What that is nothing but a corrosion that is happening for different phenomena. So iron is exposed, water is there, water is eating the iron. So, or salt is salt that is uh, used for to keep the roads clean from snow and ice. It's attached to the back to the car, and then it is eating it up. So the corrosion is a phenomena that we very often see and experience in our everyday. And this is why, let's say, we paint the car. This is why it's good that before winter we put a layer of protection on the at the back of our car, at the behind our car, where it is close to the street, so that it protects it from the possible corrosion that may happen. Acids or bases are, if they are not handled properly, they may cause a lot of damages. However, we never stop using them. And some of the uses of the acids and bases are found even in our everyday life, for, as I said, for our cleaning, usually for our cleaning, for making soap, for making laundry, and doing all the other things. So hydrochloric acid, uh, it can be used, or it is used for toilet cleaner. It's a toilet bowl cleaner. Carbonic acid, on the other side, is for the soft drink, so we drink it. Sulfuric acid is used as a solvent in the batteries of our car. Nitric acid, it is to remove that wart uh, that, on our skin. We have like a calluses, and then it helps to remove that skin, and so that works. So that this is some of the uses of the acids. While as a base, sodium hydroxide, which is a strong base, is used on manufacturing soap, textile, cleaning, sink draining, and all that stuff. Potassium hydroxide is used for to make soap. Magnesium hydroxide is as a laxative, and so on. Ammonia is to revive an unconscious person, and so on. So even though that the acids and bases, if they are not used and handled properly, can cause a lot of damage into our health, uh, there are ways to use it, and this is where we go back to. We must to the importance of handling things in a proper way, as it is supposed to be handled, so that our health and our well-being is on the right place.